Hello, my name is Vikrant Jain, and this is my public lecture video for Physics 2211. The most fascinating lecture I found during my semester was the one about dealing with gravity and diving more into its concept and learning more about it and its mechanics behind that concept. And the question of the journey through the center of the Earth was really, to me, mind-boggling and something I would definitely enjoy thinking about and understanding. The question dealt with how if you could drill a hole through the center, through the earth, and then drop into it, how long it would take for you to pop up on the other side. And that was a very fascinating thing to think about because at first I thought, well, it would just be g, which is 9.8 meters per second squared. And that would be my initial acceleration at the surface acceleration of gravity. But then later when we dove into how the formulaic basis behind it, I found how g equals the universal gravity constant times the mass of the Earth divided by r squared. And r is the radius of the Earth. Also, I understood how after learning more about it, how the acceleration would progressively get smaller as I approached the center of the Earth because my weight would be zero as I flew through the center of the Earth. And during this hypothetical journey, for this problem at least, I like one thing I would like to know is we assumed that Earth would be of uniform density, and we neglected any air friction and the high temperature for this trip, obviously, to make it possible. And so that was another key factor for me to understand how external forces play into this journey. Some of the stuff I learned during this discussion and learning more about this concept was that for a spherically symmetric mass, the net gravity force on an object from that mass would only be that due to the mass inside its radius, and that would act as if it were a point mass located at the center. And when this was analyzed in detail by me, I found that the gravity at any radius r less than the radius of the Earth would be linearly proportional to the distance from the center. And that was a very interesting pattern for me to think about. Taking positive r as outward from the center of the Earth, the equation of force equaling negative mg times r over the radius of the Earth is an equation that I found to be the same form as Hooke's law for a mass on a spring, because it would cause the trans-Earth traveler to oscillate back and forth through the center of the Earth like a mass, almost like a mass bobbling up and down on a spring. And just comparing these different situations and what we're learning help me understand how all these concepts are kind of interconnected in physics. We could even connect these to oscillation in terms of the period of oscillation, which could equal 2 pi times the square root of the mass times the radius of the Earth over mg. And that was very fascinating for me to think about as well. Lastly, the most fascinating thing I thought about this problem and what we learned during lecture was how the traveler, when it accelerates towards the center of the Earth, would actually be momentarily weightless when it's passing through the geometric center, because of the mechanics behind, the physical mechanics behind his motion. And that was just very something interesting for me to think about, because unless he or she grabbed onto something, they would fall back for a return journey and continue to oscillate with a round trip time of whatever it was. I think I remember him saying it was around 85 to 90 minutes. And that was just very interesting for me to think about, and what I wanted to note for this video as the lecture, as the one that I found to be the most fascinating.